VLSos here. This is a video lesson on the graph of tangent. Tangent, the trig ratio. So we're going to graph the equation y is equal to the tangent of the angle theta. And we're going to approach tangent with the definition that tangent is equal to sine over cosine of theta. And to get to the graph of tangent from sine and cosine, we will sketch a graph of sine and cosine. And label some tick marks to guide our graph. Sine starts at the origin, has a period of 2 pi, reaches a maximum at 1, goes through the horizontal axis at pi, completes the period, and keeps going. Cosine starts at its maximum 1. It has a period of 2 pi. It intersects the horizontal axis at pi over 2, a minimum at pi, another horizontal intersection at 3 pi over 2, and completes a period and keeps going. So here we have sine and cosine. So where do we get to tangent from that? Tangent is sine divided by cosine. And because this is a quotient, there are several places on the graph of sine and cosine which can help guide us and form the graph of tangent. We know that if cosine is in the denominator and we can't divide by 0, then every time cosine is 0, tangent is not defined. And we'll have a vertical asymptote of tangent when cosine is 0. So cosine can observe to be 0 here and here and here. When cosine is 0, tangent will have a vertical asymptote because we can't divide by 0. So I'm going to put vertical dotted lines where cosine is 0. I'm going to change how I labeled these because I made a mistake before. This is the cosine curve, and this is the sine curve. Every time cosine is 0, tangent is not defined. Similarly, when sine is 0, because sine is in the numerator of this definition of tangent, then tangent must also be 0. So where sine is 0, tangent is 0. Sine is 0 here, 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 and here. And so these places where sine is 0 are also on the tangent graph. Those are points that will be on the graph of tangent. When sine and cosine are equal to each other, then tangent is 1, because something over itself is 1. So where is sine and cosine equal to each other? Where they intersect. The sine and cosine curves intersect here. They're equal to each other, which means that it's something over itself, and tangent is equal to 1. So at this location, tangent is equal to 1. I can place that point on the tangent graph. Sine and cosine intersect here. They're equal to each other, so the tangent is 1. Sine and cosine are equal to each other here. They're both negative, but those negatives will cancel out, making tangent equal to 1. Sine and cosine are equal here, even though they're negative. Something over itself is equal to 1. Last points that we're going to establish on the tangent graph are when sine and cosine are equal to each other but opposite in sign. Sine and cosine have equal magnitude here and here, but cosine is positive and sine is negative. So it's something over itself but opposite in sign, which means that it's -1. So where sine, cosine here are equal but opposite, tangent is -1, which establishes this point on the tangent graph. Sine and cosine are equal in magnitude but opposite in sign here as well, making a tangent of -1. And here, every point that we have is on the graph of tangent. Now I can connect these points to finish the graph of tangent. Guided by these asymptotes and these 3 points, it's not going to be a straight line, but it's going to be a curve that will go through these points and the same type of curve at each of these 3-point locations in between the asymptotes. And finally, in order to see the graph of tangent, which is these curves, I'll soften sine and cosine, which it came from. This is a graph of tangent. It's periodic. These curves will go forever in both directions to infinity and -infinity. Tangent looks very much like a cubic curve, but it's not a cubic curve, it's a tangent curve. The period of tangent is pi. It repeats every interval of pi. The first graph of tangent is within -pi/2 and pi/2. That is the iteration of the tangent curve that is around the origin. And this repeats every space of pi. Again, tangent looks cubic, but it's not. A cubic function is its own parent function, and tangent is its own function as well. The curves are similar, but not the same shape. The domain of tangent is all x that is not equal to pi/2 plus integer multiples of pi. And we can express that as x not equal to pi/2 plus pi n, where n is an integer. The domain is all numbers, but you can't find the value of tangent at places that have a vertical asymptote. That would be a division by 0 error. And those vertical asymptotes are located at pi/2 plus and minus any integer amount of pi. There are an infinite number of vertical asymptotes. And the range of tangent is all real numbers.